There is one important point to note here. When I say that ln x is bounded above by each of the functions gh of x, this is when h is greater than 0. So it is for h, you can see from the diagram, it is h equal to 0.25, h equal to 0.1. Basically, we are moving towards 0, but h is moving towards 0 from above. Then we see that ln x is bounded above by each of the functions gh of x. But if h is less than 0, the analysis remains exactly the same. But in that case, ln x is bounded below by each of the functions gh of x. We see h is equal to minus 0.25. Then we see h is equal to minus 0.1. Basically, h is nearing towards 0. H is moving towards 0 from below. So the analysis remains exactly the same. It's just that when I consider h greater than 0, I see ln x is bounded above by each of the functions gh of x. When h is less than 0, the analysis remains the same. But in that case, we say that ln x is bounded below by each of the functions gh of x. I now take up logarithms with base other than e, and before that, if we can recall ln x, because we were till now concerned about natural logarithmic function, and there the base was e, and if I have to understand ln x is nothing but the exponent or the power to which we have to raise e in order to get x. But now let us suppose a is a positive number, and we usually choose a to be greater than 1, usually chosen greater than 1. This is precisely because of this fact. If we recall what we did in chapter 3, that when I say a quantity is increasing exponentially, that means it is increasing by a fixed factor per unit of time, and let us say that fixed factor is a, and if the quantity is increasing by that fixed factor a per unit of time, we say that the quantity is increasing exponentially. And in that case, this was our exponential function f. Little a and capital A are positive constants. Here we know that if 0 is less than a less than 1, then f is decreasing. But if a is greater than 1, then f is increasing. We are concerned about a quantity that is increasing exponentially or a quantity that is decreasing exponentially. When I say it is increasing exponentially, that means the quantity is increasing by a fixed factor per unit of time. Or if it is decreasing exponentially, that means it is decreasing by a fixed factor per unit of time. We are usually concerned about a quantity that is increasing by a fixed factor per unit of time. That is why we usually choose a to be greater than 1. Keeping that in mind, if I have a as a positive number, which is usually chosen to be greater than 1, and now I write a raised to the power u equal to x. Now in this case, I can say that u is the logarithm of x to the base a, and that means I can write u to be equal to log of x to the base a. Basically, in this case, we are concerned about when I write log of x to the base a, it is the power to which I have to raise a in order to get x. So a raised to the power log of x to the base a is equal to x, and u is equal to log of x to the base a, given that a raised to the power u is equal to x. So this is something we have to keep in mind. When I write log of x to the base a, it is the power to which I have to raise a in order to get x. For example, if I write log of 32 to the base 2, this is going to be equal to 5 because this is the power to which I have to raise 2 in order to get 32. So 2 raised to the power 5 is 32. That is why log of 32 to the base 2 is equal to 5, because 2 raised to the power 5 is equal to 32. In other words, I can write that this, it is the power to which a has to be raised in order to get x. If I write log of 1 by 100 to the base 10. Now in this case I have log of 1 by 100 to the base 10, and this is going to be equal to minus 2, precisely because 10 raised to the power minus 2 is equal to 1 by 100. And if I write that again, a raised to the power log of x to the base a is equal to x. I take ln on both sides, I take the natural logarithm on both sides. So in that case, I will have log of x to the base a ln a is equal to ln x, and that gives me log of x to the base a is equal to 1 by ln a multiplied by ln x. This is also something to be careful about, because this reveals that the logarithm of x to the base a, it is proportional to ln x, and the proportionality factor is 1 by ln a. Log of x to the base a is equal to 1 by ln a multiplied by ln x. So that means I can see that the logarithm of x to the base a is proportional to ln x, but the proportionality factor here is 1 by ln a. We have to note that this actually means that whatever rules were followed by ln, the same rules would be followed by log to the base a. So let's understand those rules. Log of xy to the base a will be equal to log of x to the base a plus log of y to the base a. If I have log of x by y to the base a, this will be equal to log of x to the base a minus log of y to the base a. If I have log of x to the base x raised to the power p to the base a, which is equal to p multiplied by log of x to the base a. Also, I have log of 1 to the base a, that will be 0, because a raised to the power 0 is equal to 1. And I can also write log of a to the base a, that will be equal to 1, because a raised to the power 1 is equal to a. Let me just take up one rule, and if I have log of xy to the base a, and I know that this is the case, log of x to the base a is equal to 1 by ln a multiplied by ln x. That means I can write this is equal to 1 by ln a multiplied by ln xy. This can then be written as 1 by ln a and ln xy can be written as ln x plus ln y, which can then be written as 1 by ln a multiplied by ln x plus 1 by ln a multiplied by ln y. This expression is nothing but log of x to the base a. This expression is nothing but log of y to the base a. So that means I can write log of x to the base a plus log of y to the base a, and that actually proves the very first rule. Also, we have to keep this in mind that if I have y is equal to log of x to the base a, and I know that log of x to the base a is equal to 1 by ln a multiplied by ln x, that means I can think of what y prime will be, and that will be equal to 1 by ln a multiplied by 1 by x. So this is also something to be careful about, that if I have y is equal to log of x to the base a, y prime is going to be equal to 1 by ln a multiplied by 1 by x. We are keeping in mind the fact that log of x to the base a is nothing but 1 by ln a multiplied by ln x. Keep this in mind that logarithm of x to the base a is proportional to ln x, and the proportionality factor is 1 by ln a.